C# is a powerful but simple language aimed primarily at developers building applications for the .NET framework. It inherits many of the best features of C, C++, and Visual Basic, but few of the anachronisms and inconsistencies, resulting in a cleaner and more logical language. The purpose of this presentation is to provide an overview of the features and syntax of C# from a Java perspective, showing how the languages are similar, but also highlighting some of the significant differences that a Java developer should be aware of. This presentation will also describe some of the extended language elements of C# that are not currently available in Java, although future versions of Java may include some functionality that is similar. The original Windows software development kit used by most developers building professional Windows applications was based on a set of C APIs, as C was the programming language of choice at the time. By the late 1990s, C++, the natural successor to C, had established itself as a language for building object-oriented solutions. The Windows SDK had been updated and augmented with a large number of C++ APIs, and the Windows API was updated to exploit a C++ object model. However, although most developers were comfortable with the basic syntax of C, their general feeling amongst many developers at the time was that C++ was overly complicated and suffered from a glut of features that sometimes compromised the ability to build reliable software quickly and easily. Consequently, a research team at Microsoft, led by Anders Heilsberg, took a step back and decided to engineer a sleeker language employing the familiar syntax of C, but with a more straightforward model for implementing object-oriented solutions. The result was the first version of C#. The developers at Sun Microsystems originally adopted a similar strategy for Java. Consequently, there is a lot of similarity between the syntaxes of C# and Java. Despite their common ancestries, the overall aims of C# and Java are subtly different. The purpose of Java was to provide a programming language to support the Java Virtual Machine, or JVM, a cross-platform runtime environment that abstracted the operating system and hardware concerns away from an application. Any Java application can run unchanged on any computer that supports a JVM, and the behavior should be the same. The purpose of C# was to provide a simple, clean programming language targeting the Common Language Runtime, or CLR. The CLR is intended to provide a cross-language platform for the Windows operating system, and consequently C# was not originally mooted for use across multiple operating systems. As time has progressed, the distinctions between the purpose of the JVM and CLR have become more blurred, especially as open source versions of the CLR are now available for operating systems other than Windows, and other languages are now available that can target the JVM. The CLR is now a fundamental part of the Windows operating system, and it supports many different types of environments. Consequently, C# has become the key development language of choice for most Windows applications, whether they be running on a desktop or in a web browser, hosted by a web server such as IIS, cited on a mobile device such as Windows Phone 7, or running in the cloud by using Windows Azure. Because of their common ancestry, the basic syntaxes of C# and Java are very similar. For example, both languages are block structured using curly braces to delimit sections of code, and both languages provide common programming structures such as if-else blocks, for, and while loops. In other cases, Java and C# use a different syntax or keyword to implement the same semantics. Examples of this are the super keyword in Java, which equates to base in C#, and the implements and extends keywords in Java, which are both denoted by using a colon character in C#. Java also provides some keywords which have no equivalent in C#. An example of this is throws, used to specify the exceptions that a Java method can throw. The C# model does not require a method to declare this information, so the throws keyword is not provided. Finally, some Java keywords have no corresponding C# keyword, but the equivalent functionality is instead provided by types in the .NET Framework base class library. Examples of this include the Java assert keyword. The .NET Framework provides the static assert method of the debug class, and the Java transient keyword. The .NET Framework provides the non-serialized attribute to implement the same functionality. In a similar vein, the fundamental data types of C# are very similar to those of Java, although there are some important differences and additions to be aware of. For example, C# has unsigned versions of the integer data types, such as uint and ulong. The byte data type in C# is also unsigned, and the sbyte data type is signed. making it equivalent to Java's byte data type. The basic operators built into the languages also share a lot of commonality, although as before there are some small differences, such as the behaviour of the bitwise left shift operator. In Java, this operator performs a signed operation, whereas in C# the same operator performs an unsigned operation. An interesting addition that appeared in C# 3 was the use of the var keyword to indicate a variable of an unspecified type. However, variables that you declare using the var keyword are still strongly typed. It's just that the compiler determines the type from the way in which the variable is initialized. Once the variable has been assigned a value, it cannot be assigned a value of a different type. The var keyword is frequently used in conjunction with link statements, which are described later. The C# language includes some keywords that have no counterpart in Java. Many of these keywords are described in more detail later. Additionally, C# provides a selection of additional operators. For example, the null coalescing operator is used to check whether an expression is null, returning a program-defined value if it is. Many of these keywords and operators are designed to support interoperability with Windows applications that run outside of the protected environment provided by the CLR. Others are part of the syntax that C# implements to support generics and lambda expressions. Here is an example of a simple program for both Java and C#. At first glance, the structure of both programs is very similar. However, there are a number of subtle differences between them. First, classes in C# do not have to have the same name as the file that they are contained in. The main method is also not required to be made public. One thing to remember is that the name of the main method in C# must also start with an uppercase M. The using keyword in C# brings a namespace into scope, similar to importing classes in a Java application. In this case, the namespace containing the console class has been imported. As an aside, the system namespace contains the common classes and types used by most C# applications and is analogous to the java.lang package in Java. However, although you do not need to explicitly import the java.lang package in a Java application, if you require types from the system namespace in a C# application, you should bring it into scope with a using statement. A namespace is the equivalent of a Java package. In C#, a namespace can contain multiple classes and be spread across multiple code files. The syntax for defining methods in Java and C# is very similar, as is the syntax for instantiating an object and the way in which methods are called by using an object reference. You define classes in C# in a very similar manner to that in which you define classes in Java. Like Java classes, C# classes can contain methods and fields, and these methods and fields can be defined as public, private, or protected, depending upon whether they should be visible to other classes. There are some subtle differences that you should be aware of, though. Java classes can also be designated as final to prevent them from being inherited. In C#, the sealed keyword achieves the same result. A protected method in Java has package scope. It's accessible by all other classes in the same Java package. In C#, a protected method is accessible by the class in which it is defined and all child classes that inherit either directly or indirectly from it. It has inheritance scope. The closest equivalent of the Java protected keyword in C# is internal, which limits access to other classes defined in the same assembly. Finally, C# enables you to designate a class as abstract, and these classes follow the same rules as abstract classes in Java. They cannot be instantiated and instead act as a placeholder for defining abstract methods and other functionality that a child class should implement. Like Java, C# enables you to define overloaded methods in a class. However, C# is designed to interoperate with other languages and technologies that may not support method overloading, so C# also enables you to define methods that take optional parameters. To do this, you simply specify a default value for a parameter as part of the parameter definition. If the method is invoked without specifying the value for a specific parameter, its default value is used instead. C# also supports named arguments. These are the corollary to optional parameters and enable a C# application to invoke a method without having to provide a value for every parameter. The syntax specifies the name of the parameter, followed by a colon, and then its value. Any parameters omitted will be given their default values. In Java, a method must declare any exceptions that it throws as part of the method definition. CSharp doesn't have this requirement. To actually throw an exception in CSharp, you use the throw statement as you would in Java. To handle an exception, you use a try-catch block and specify the type of the exception to process. In CSharp, to handle all possible exceptions, you can catch the system.exception type. If an unhandled exception occurs, the exception propagates out to the calling method and continues propagating until an appropriate handler is located. The program terminates with an unhandled exception if no handler is found. Also like Java, a CSharp method can implement a finally block, which is always executed after all the try-catch processing has been completed. In Java, variables that you declare by using the primitive types such as int or long are passed by value as method parameters and return values using the stack. Variables that you declare based on class types are allocated memory on the heap and are passed by reference as method parameters and return values. The same is true in CSharp. However, CSharp enables you to pass value types by reference if necessary, by using the ref keyword. You can also declare reference parameters as output parameters by using the out keyword. Output parameters must be assigned a value by the method before it finishes. As with Java, CSharp supports single inheritance only, but with a slightly different syntax. CSharp uses a colon, where Java uses the extends keyword. Additionally, in Java, methods are virtual by default. To override a method in a derived class, you create a method with the same signature. The designers of CSharp felt that the approach followed by Java was potentially dangerous and could lead to subtle errors caused by accidentally overriding a method. Therefore, in CSharp, methods are non-virtual by default, and you have to explicitly declare them as virtual if you wish to override them. Additionally, a derived class should specify the override modifier to indicate that it is intentionally overriding a virtual method and not accidentally creating a method that happens to have the same name. Incidentally, over time the Java community realized that accidental overriding was a rich source of potential bugs, and as a result added the override annotation in Java 5. Like Java, you can define and implement interfaces by using CSharp. Also, as with Java, a CSharp class can implement multiple interfaces. The main syntactic difference is that CSharp uses a colon, where Java uses the implements keyword. CSharp also allows you to specify that an interface should be implemented explicitly. This can be useful to help resolve any ambiguity if two interfaces happen to define the same method names. When an interface is implemented in this way, its methods can only be invoked by specifying the interface type. The CLR and the JVM both implement garbage collection, freeing Java and CSharp applications from the need to worry about reclaiming memory when objects are destroyed. By default, both environments follow a non-deterministic approach in that the CLR or JVM decides the most appropriate point for destroying objects and reclaiming their associated resources. However, the CLR also supports a deterministic model, and CSharp applications can exploit this feature to indicate the point at which an object should be destroyed or disposed. A disposable object is a type that implements the iDisposable interface and provides a dispose method which is called by the CLR to deallocate resources. The C# using statement declares one or more disposable objects and a scope for these objects. The objects are created at the start of the statement and are destroyed when the associated code block completes. As an aside, you should not confuse this version of the using statement with the using keyword that brings a namespace into scope. C# just happens to give the same keyword two meanings depending on its context. In C#, a file can contain multiple classes, and the names of these classes do not have to be associated with the name of the file they are in. Partial classes enable the definition of a single class to be split across multiple files. Partial classes are useful when working on large projects, as multiple developers can work on different parts of the same class at any one time. Partial classes are also very useful for building templates and application frameworks that generate code. A code generator can automatically construct the code for a class as a partial class, and enable a developer to augment this generated code with specific functionality. Because the generated code and the code written by the developer are in separate files, the developer's code will not be lost if the framework code is regenerated. Tools such as Visual Studio make extensive use of partial classes for generating the layout code for GUI applications. You implement a partial class in a similar manner to a regular class, but by specifying the partial keyword. When a program is compiled, the code for the partial class across the two files is combined into a single entity. Partial methods are a key feature of partial classes and provide an important extensibility feature frequently employed by code generators. The code for a partial method may be located in a different file from the code that invokes it. When a partial class is compiled and the files that comprise the class are combined, all calls to partial methods are resolved. If no such method has been implemented in any of the files, the method call is silently discarded. In Java, properties are simply methods that typically store or retrieve the value of an encapsulated field in an object. Most Java tools expect them to be implemented with a specific naming convention, such as setFoo and getFoo, where foo is the name of the property. Alternatively, Java also provides the properties class in the java.util package, which can act as a collection of property values. In CSharp, properties are first-class elements of a class, and not just a naming convention. CSharp enables you to define set and get accessors to store and retrieve data. You can also transform data as it is read or written, performing a calculation such as converting between centimeters and meters, as shown in this example. The set accessor has an implied parameter called value that represents the data to be assigned. You can define read-only and write-only properties by omitting the set or get accessor. You access a property by using the same dot notation that you employ to read and write a regular field in an object. A property encapsulates a single value, but CSharp also lets you define indexers, which can encapsulate a set of fields. Like a property, an indexer specifies the type of data it exposes, together with get and set accessors. The syntactic difference is the array-like notation for declaring them. You define an indexer by using square brackets and providing a parameter that acts as an index. You reference an item to an indexer as though it was an array. Unlike Java, CSharp supports programmer-defined operators through operator overloading. You can overload a limited set of operators by defining static methods using the operator keyword together with the symbol of the operator that you are overloading. The results are arguably more predictable and easier to understand than the equivalent features in C++. In Java, you have a limited set of value types, the primitives that are built into the Java language. CSharp enables you to define your own custom value types by using the struct keyword. Structs in CSharp are similar to structs in C++. They can contain methods and they can expose properties, much like a class. Indeed, the syntax for defining a struct is very similar to that for defining a class. There are some restrictions though. The most important of these is that structs cannot inherit from other structs or classes, although they can implement interfaces. You typically use structures to model items that contain relatively small amounts of data. In fact, many of the types built into CSharp are actually structs. For example, the int type is actually an alias for the system.int32 struct, and you can invoke any of the methods of this type on any int variables that you define. In C#, a delegate is a pointer to a method which works in a similar way to a function pointer in C or C++. A delegate specifies a method signature. The delegate can refer to any method that matches this signature. When your code invokes a delegate, it behaves exactly like a method call, passing parameters and returning values. A lambda expression is an expression that returns a method. You typically use one in place of an anonymous method if the purpose of that method is simply to provide some one-off functionality. A common situation is instead of a delegate, where a lambda expression provides a neater and more concise syntax. A lambda expression comprises three elements: the list of parameters, the lambda operator, and the expression that defines the functionality. Lambda expressions are due to be included as part of Java in the form of closures with the release of Java 7. Events enable an object to be alerted when a significant action occurs within an application. Events are frequently employed in GUIs, where a user can visit the controls in a window in almost any sequence. When the user selects a control or performs an application, such as clicking a button, the control can raise an event and notify the application. The application can then perform the appropriate processing. Events are built into the C# language. You can define an event by using the event keyword, typically adding it to a class that acts as the event source. Other objects can subscribe to an event and act as an event sink by using a delegate and adding it to the event by using the += operator. You can also unsubscribe from an event by using the -= operator. The form of the delegate that a subscriber must use is defined by the event. It is commonplace for a subscriber to implement the delegate by using a lambda expression. To trigger an event, you simply invoke it like a method. This action causes all the subscribing delegates to be invoked. C# introduced the Language Integrated Query Facility, or LINQ, as part of C# 3. LINQ provides a concise syntax that enables a programmer to construct queries over enumerable data. This data might be contained within a collection of objects, a database, an XML document, or a variety of other enumerable sources. LINQ employs a syntax that is reminiscent of SQL. You specify the source of the data, any possible conditions to match against, and the actual elements that you wish to retrieve. The value returned is an enumerable collection, which you frequently specify by using the var keyword, as mentioned earlier. You should be aware that this collection is not actually enumerated and the data retrieved until you iterate through it. C# is a strongly typed compiled language. Language interoperability is a key aim of the CLR in C#, and it works well with other compiled languages that also target the CLR, such as Visual Basic and Visual C++. However, many developers are increasingly building components by using dynamic scripting languages, such as Python, Ruby, PHP, and JavaScript. The .NET Framework provides a Dynamic Language Runtime, or DLR, on top of the CLR to allow C# and other compiled languages to interact directly with components developed by using dynamic languages. The DLR provides services that can locate and invoke methods in a dynamic object at runtime. This means that any type checking and object referencing cannot be resolved at compile time. C# provides the dynamic keyword to indicate that a variable is a reference to an object through the DLR and defers type checking and resolution for the object to the DLR. The next version of the JVM, with Java 7, is expected to include a similar level of support for dynamic languages. C# and Java share a lot of syntax and features as a result of their common ancestry. Consequently, as a Java developer, it shouldn't be too difficult for you to quickly become productive with C#. However, C# also has a lot of new functionality to offer Java developers. Features such as partial types, delegates, and LINQ go a long way in helping a developer to create simple and efficient code. While some of this functionality will be added to the upcoming releases of Java 7 and Java 8, C# provides the ability to use them now in a mature and stable format. Together with tools such as Visual Studio, C# is the ideal language for producing highly functional software that can run on the Windows Phone device, the Windows desktop, across the web, or in the cloud through Windows Azure.